All right, seems to be there live. Let's see how many people show up. I'm gonna keep this for a little bit, and then we are gonna head to show some demo. Cool. So thank you for joining the launch of Oracle to Postgres translation in SQL Tran. I'll keep this a little bit informal. Please use chat to ask questions. Please use chat if you want to send me some files to test. I just wonder, where can I see how many people have already joined? All right, let me see if I can open this in Luma. Okay, do I need to start? This is the first time I'm doing, which I'm sure you can already see. If I start the event in Luma, that should basically be it. All right. Cool. So I trust there's going to be at least someone here. Please don't hesitate to use the chat to communicate with me. I'd much rather speak with people interactively than just going and doing my thing. All right, so as just a small intro, who are we? Spectral Core is a database migration company. We've been doing this for over 20 years now. We started with small business software. Now we are mostly in enterprise space. Our flagship software are OmniLoader and SQL Tran. OmniLoader is software designed to move enormous quantities of data between databases extremely efficiently and quickly. And then SQL Tran is our newer product, which is used to translate complex database code. So table definitions, but also views, procedures, functions, triggers, packages, package procedures, all kinds of things. And this has always been very complicated things to pull off, right? There are quite a few tools doing that on the market. These tools are slow, complicated to use. They are not as accurate as I would prefer. We decided it's time to do something better. But as covering the full surface area of database dialects is very, let's say, enormous task. It took us years to build this. However, what do we have now? We have a translator that's by far the most accurate on the market, by far the fastest on the market, and it has some functionality that basically nobody else has. And I'm saying that this software is more accurate than what we currently have on the market. Well, the industry standard is, regardless of what each vendor will say, the industry standard of what an automated tool, top of the line automated tool can pull off is 50% to at most 70%. And regarding the speed, right, if you're going into the more serious code base, let's say 500,000 lines of code in a database, well, it's going to take a day or two, right? Just for the tool to do the assessment and then for the tool to do the translation, then let's not even start about the testing. Well, our tool will do that in seconds. And our tool will create the target database right from within the application, so live database. And it's also gonna test everything. So we have the full coverage from the initial script to the live tested database. It takes very, very little time. Okay, I'm going to just start showing you things, and then please go ahead and write into chat if you have anything. Let me see if you can see my screen. Right, so maybe the screen should show up now. So hopefully you are seeing my screen as I speak. So what you see here is SQL Tran. SQL Tran is basically SaaS application, which allows you to use it like any web application, right? What we have is create new project, DDL translation project. Let's start here slowly and see how this works. So I'm going to click new project, and then there is a number of supported sources. So remember, this is the database code translation. We have a companion application called OmniLoader that's for the migration of huge databases or small databases, which OmniLoader supports data copying, comparison on demand, sync on demand, but also change data capture for continuous transaction streaming between heterogeneous databases. So SQL Tran, which we are looking at now in combination with OmniLoader, provides a full data and code migration solution. All right, on the left side, we'll see the steps. There's quite a few steps, but don't worry, it takes just a little bit of time. So first, we're gonna select our source database, and now we can upload our source database schema. If you don't have a source database schema as a SQL file or a zip file containing potentially hundreds or thousands of SQL files, you can also connect to your source database directly, and we'll pull the schema for you. You can also run our free CLI command line tool to create the schema for you. So if you're in the walled garden, you can use our tool to extract it. Also, if you go to our documentation, we have a script in case you don't want to run any tools. We give you the script to create your schema using just SQL. All right, so I have some SQL scripts here. And first, let's test my claims that this tool is super fast. So I have two customer database schemas that are anonymized. I'm not going to go in depth and show the detailed structure, show you their code, because this is not mine. But let's see how much time does it take for us to fully translate them. So the first one is 85,000 lines of code. All right, uploaded. Only Postgres is supported at the moment, going from Oracle. And so let's call this 85K slok database. I'm going to click next. So far we didn't even start doing anything, right? I'm going to click next, and we are doing parsing, static analysis, translation, and we are done. So for this database, which has 85,000 lines of code, 2,000 objects, 1,200 tables, 96 procedures, 500 triggers, we are almost 100%. We have one object that wasn't translated correctly. And that's because we currently don't support DBMS SQL parse, right? There's actually, this is not the latest version, but I have a feature freeze before the demo. So in basically a week or so, we're gonna release even more improvements to this software. All right. If you see these red lines, don't be scared. Don't think that this is that like 2 quarters of static analysis failing. No, this is there's just 17 functions here, and they have a bunch of problems but this is not actually related to a tool, it's related to a script. All right, so you've seen how much time it took us to translate 85,000 lines of code. Let's go to something even more significant. Let's go to 500,000 lines of code. So let's call this 500,000 slok or Postgres. Next. All right, so we are parsing, meaning building semantic model, static analysis, meaning figuring out every single name and reference. Where does it go? What is it, right? And static analysis helps us in translation to get to this 99% fully automated translation. As far as I know, we are the only vendor doing a full static analysis on the whole database, right? Okay, so 500,000 lines of code. This example database actually doesn't have procedures. It's mostly just tables and views. You'll see, yeah, basically tables and views. But look, we are again roughly at 100% translation. There's only one error, and that's NLS calendar not implemented. All right, so let's now go with one of the demo databases that we have. And we are going to show a few more things because this one is actually ours. So I'm going to click New Project, Oracle. Again, I'm going to upload the script. Let's go to Demo. And this is a script I innovatively called Launch. And let's call this Launch. So when I click Next, it's going to do everything. All right, so this is a smaller script, just 14,000 lines of code, 14.6K. And we are able to do absolutely everything. So now I'm going to go a bit more in depth so you know what you are looking at. So first, this is a full object lifecycle here. We go from parsing, which means building semantic model out of the just text, right? And then the next one is static analysis. As I mentioned earlier, this follows every single name reference and figures out what is it. Importantly for us, it also catches all the broken reference. So when you have broken code, we'll catch that. If you have, for example, customer script and the customer didn't give you all the objects, for example, some tables are missing or some views are missing that other objects are relying on. Well, we don't need a live database to figure out the data lineage. We do everything ourselves. And you see how quickly we can do that, right? And then comes the translation. Well, this step is building, going from Oracle dialect to a Postgres dialect. And we are building idiomatic Postgres. I'm going to show that. And then the last two stages are something that's not really seen in the wild, right? The creation step allows us to create a live Postgres database. So coming from just Oracle SQL dump, we go to the live Postgres database instantly. And again, we'll see the full statistics here. If anything is failing, we'll see that. And the last step is really unique to us. This is full testing. And again, I'm going to go in depth here. Complexity of object. This is a histogram of complexity, as this is a small demo database here, but it's not a trivial demo database. So again, I'm going to show a bit more about it. We see exactly how many simple objects you have, how many medium, and how many complex, and so on. And by complexity, we don't mean number of lines of code. We mean semantic nodes, this weird number here. So we know exactly, because we are building our own semantic model. And we built everything from scratch. So we built our own parsing engine, parser generator, static analysis. We built our own we are in full control of everything. We know exactly what's in the whole database. And even if you have a database that has, for example, 2 or 3 million lines of code, and we have such customer database, this will work in exactly the same way. just the numbers will be larger. Just for your information, number of nodes, so semantic nodes in a single line of code depends on the code style. But on average, let's say 5 to 6 nodes per line of code. It depends on the code complexity and style. All right, then we have a list of most complex objects, and what's empty here is a pane with problems, right? So let's go and just, for example, I'm gonna load the complex one. Well, this one has a bunch of issues that I wanted to use to show you what can happen. So for example, this script has a syntax error. It has some duplicate object definitions. And we can basically either download the invalid SQL, or we can create the project skipping the invalid stuff, right? And here you'll see the pane with the error types. So we see that, for example, there are these edge cases which we currently did not implement. Some of them will implement, some of them we won't implement. But if I, for example, go and say, see all errors here, we have a report for that. But if we go to the workspace here, so the next tab, now we'll go a little bit more in how you use this thing. If you go to the workspace tab and we see everything inside, right? But there's one tab so this is standard metadata tree, right? All of the views, procedures, right? And there's also the errors tab. So you can immediately see what is the problem, right? So for example, we don't support some things here. All right, let's go back to our demo database. And so far, I did nothing special, right? I have just translated it. To translate it, I need, so by the way, some of these things are only here for me to help me with demos. For example, Scratchpad is for me, reparse, retranslate. If I retranslate, we can translate 250,000 lines of code per second. And that's for the small one, right? So I think we need something like 20 seconds for I measured it, 2.7 million lines of code database, 20 seconds. All right, that's not that important. What's important is that it's actually accurate. So if I go to workspace here you see types, all the types in the database. We don't create most of these types, and because it depends on how we are translating this. And now if you go table to table, you'll see, okay, here's the source, this is the equivalent here, right? Now, I don't want to go and scroll all the time and click on the names, right? What I want to do is quickly find them. So I can say, for example, so if I start, for example, let's say admin ext ample HR new, I can go very quickly, right? If I go and, for example, search for employees, I can also go ahead and use my mouse or use my keyboard, continue type. By the way, in this version, we don't have completely set up the static analysis on the target side. So I'm gonna just disable this temporarily. All right, so this is the source, this is the target. However, what's interesting is the data lineage that's built in. So this specific table here, I have someone in the chat. Give me a sec. Text is not legible. All right, so let's see. I can make this larger. I hope this is better. Is it okay now? Please just Raja, write in the chat if this is better, right? Okay, so we have the list of objects on the left side, and we have the source, we have the target, and here we have the full data lineage model. So what does this mean? It says this table, SQL Tran employees, is used by these objects on the right. So they are relying on this specific table. And not only do we see the list, we see exactly what they're using it for. So we see, for example, it's being used in the package body, but this one, this is a procedure, HR report package. It's updating and it's inserting into this table, right? So we immediately know what is read-only surface area and what can actually write and change the state in this table, right? So I can, for example, just click here and all right. Oh, so this is a package here, and I can now go ahead and find it somewhere in here, right? So this is inserting into employees backup, right? And then this is selecting. Yeah. All right. So now you see that we have a bunch of packages here. And I'm just going to close this temporarily. So packages are not supported in Postgres. So we are emulating them. And we are emulating them by using basically set config and current setting. And this works very, very nicely, right? So the package needs to be initialized because Postgres simply does not have the functionality that Oracle has here. Then we have a bunch of views, and you can see that we have all this connect by, it's emulated here, right? And then, for example, we have all kinds of complicated aggregations. Yeah, so for example, if I go and search, yeah, by the way, you've seen how I used quick find, right? For example, employee object, or I can say stuff like this, right? And quickly navigate. However, I also had a full text search over the whole project. So for example, if I want to find list egg here, right? I see all the places where this is used. And I see exactly that, for example, we are now emulating this. So we try hard not to call the external extensions. If there is a need, for example, use spatial unit Postgres, right? In rare cases, we will use Aura FCE. But most of the time, 99% of the time, we translate everything out of the box because we want this to be usable in open source Postgres. So we don't want to lock you into another platform. We don't want to lock you into EDB. We don't even want to lock you into some specific AWS extensions, right? So this tool is specifically designed for the migration to open source Postgres, which means, yes, you can use it on all the platforms. You never have lock-in, right? Okay, now, I've been mentioning static analysis. What does static analysis even mean, right? Why do we need something like that? So let's hover over this. This is order ID dataset column, which is actually pointing to order products table. If I go to order products table here, okay, let's see, this is reference to that specific table. I immediately see what is it, right? If I now go, for example, into a procedure, let's say this one, right? Again, if I hover here, I know exactly what this is, right? If I hover over this, it says it's reference to a parameter, and this is an ID. So if I click F12, I'm going to navigate. See how the cursor jumped. I'm going to navigate to the definition, and I can actually go from alias to the table name in the join, and then follow that reference chain. And this is important because it allows us to always know exactly what, for example, the function's parameters are, which means that we are able to generate completely different translation based on what exactly parameters are, right? Something that other translators cannot do. All right, I'm going to finish talking about the semantic model. It's not very interesting, but just so you know, we can expand this thing, right? And then I can go and navigate inside of the complex procedure. For example, go, okay, this is the outer join clause here, right? And this is, for example, with clause, right? Okay, so I've shown you some advanced things, but what is the absolute simplest way to actually start using this thing, right? Just a moment, let me find, yeah. All right, so the last thing I wanted to show you are tests, and they are disabled here. Why are they disabled? Well, because we don't have database connections, but if you provide database connections, which is what we're gonna be doing now, we're actually gonna be able to create a target database, so live Postgres database, and we're gonna be able to create full tests. So just to make it fun, I'm gonna create a completely new project. So you see exactly how we go from 0 to a live and tested Postgres database. All right, let me see. I'm gonna create my new databases in the Beaver, and let's go ahead here. So let's go with a new one, right? So I'm gonna say launch. I have uploaded the script, Postgres. So I'm gonna call this live and tested Oracle in Postgres. All right. We're done, fully translated now. However, this is just our application thinking this is perfectly translated. Is it really perfectly translated? Well, we don't know until we test it. Now, I can, for example, add the target connection here. So I can say, let's call this launch, right? If I go back to the overview, now I have unlocked the next stage in the life cycle. So I can go to actions, target staging database, fully recreate all objects. And just like that, we now have a live Postgres database. We have connected to the Postgres database. So we go from the source Oracle script to tested live database in a few seconds, right? Okay, so now, actually, let me kill the database. And give me a sec. I'm gonna actually, let me call it launch tested. Launch tested. All right. So I'm gonna, again, let's see now how quickly can I go from just Oracle script to have a fully tested live Postgres database. So again, just for fun, let's do a completely new project. So okay, this was just live, not tested. Let's go from launch Postgres, and now this is truly tested Oracle in Postgres. Next, done. All right, now I'm gonna unlock both, actually specify both source and target connection. I'm gonna add connection to Oracle. So please don't connect to production database. This is staging or test database. This is designed to be destroyed and written into, right? And I'm gonna call this launch tested, the one that I have just created. Let's go back to overview. Okay, so now I have unlocked the last two stages in the life cycle. And now the question is, how do I test? Well, to be able to test, we need to have live source and live target data. So I need the live Oracle database that I have connected. We need a live Postgres database, and we need schema, equivalent schema in source and target. So, okay, our translated schema in Postgres will be okay for that purpose if we did the right job. And then we need to have data. And the data, again, has to be exactly the same, because if data is different, how do you compare anything? Now, what you can do is you can use our Omni loader and basically load your production data or anonymized production data into source and target. That will take some time because you need to fire up another tool and so on and so forth. But for the testing purposes, we have provided super fast on-ramp for you. So we have two empty databases, and we have only started with Oracle schema dump, nothing else. There is no data involved anywhere. So this is, let's say, a typical use case. what you'll get from your customer. And the customer typically first just give you a script. Actually, they'll typically give you part of the scripts that you need just to see what you can do, right? And then with this tool, you can basically translate it, but it's gonna flag everything that's missing, right? So you have a script and you don't have a data. So how do you test? Well, you can go and write scripts to create, to load data into 835 tables. All of this is going to take a while, but if you do it by hand, and you'll realize once you go to a certain scale, nothing is that simple anymore. You'll hit all kinds of edge case depending on the data types, data size, and so on. Right? Okay, to stop over explaining myself here, I have loaded the script and connected to empty database. I did nothing else. Well, we have initialized staging databases actually. You're about to create all object in source and target and load synthetic testing data. Are you sure? Well, I am. How many records would I like to load into each table? And we have 800 tables. We can put any number in here. However, my Oracle is somewhat underpowered. It's running in Docker here, so don't be alarmed when you see how slow Oracle is. Oracle can be very, very fast. All right, I clicked it. So what are we doing? We are now creating objects in Oracle and Postgres. And Postgres is already done. We have inserted all the data into Oracle's tables, depending on the order of the structure. We might create some tables and then wait for the others, but in the end, it's all going to be at 100%. So we are now using, I think, 4 threads to simultaneously edit data into multiple tables at once. We are generating the data that's fully synthetic, that conforms to your schema. So it takes care to generate proper data for the specific data type. So precision scale, it's going to even analyze the check constraints. So it's going to satisfy check constraints, uniqueness, foreign keys, will take care of everything for you, right? Again, this works even on 100,000 tables. We tested it. You need to give it maybe faster Oracle than what I have in this Docker in that case, otherwise it take forever. But yeah, the tool is super fast. Now you're just limited by your database servers. But yeah, this can do basically synthetic data on any scale. And if you want to have more and better data than completely made up data, well, you can use OmniLoader and load anonymized production data if you desire so, right? Okay, now we're creating constraints. If you go back to seed data, yeah, 100% constraints, indexes, everything 100%. All right, so we have, in the process of loading all this synthetic data, of course, created all the live target schema. So we have source and target schema created, and now we have data. So how do we test this thing? Well, if there is a dedicated test screen, but also we can go and, for example, test a table. We have test button, which will create a test for you. This test doesn't have parameters. There's no parameters when testing table. And actually, so I click one button, I click run tests. So what do? Well, we actually, by the grace of having OmniLoader already developed, which is able to move hundreds of terabytes easily, well, we can also, of course, compare this 1,000 record table very easily. Again, this is performance. So we have correctness testing, and we also have performance test built right into the software. Again, my Oracle here is super limited. I didn't give it enough memory so it can spread its wings. But you can use your own Oracle. You can use your own Postgres, sized exactly how you would size them, and we'll measure exactly how long does it take for us to read the data from this table. Now I can do this a bunch of times. So test and then run, and this will take too long, right? This software is built for basically enormous enormous database. I have another question. So Steven, how do you cater for the source Oracle table having triggers and then ensuring that the equivalent is tested in Postgres? Well, we don't test triggers, but we take triggers into account automatically by testing the procedures. And then whatever procedure is doing on the table, if we got the triggers right, whatever triggers are doing its thing on the Oracle side and are equivalent translated and emulate triggers on the Postgres side, the end result in affected tables has to be exactly the same. I'll come to that very soon. Raja asks, are there any memory limitation? Like SCT is limited using 4 gigabytes of RAM. Well, SCT is 32-bit, this is 64-bit, and we are super optimized. Don't worry about this. I have tested this on 2.7 million lines of code fairly recently, and I don't expect any issues. So if there, look, this software is so fast. We're actually running our SAS in a very underpowered 8 vCPU with slow Postgres to back it up. We can go to, I don't even know how many vCPU cores. So even just if we scale vertically, we can go from 8 cores to 96 cores at least, if not 256. And then we can scale horizontally. So basically, I expect exactly 0 problems with performance and memory. All right, so how do we test tables? Well, we compare that all the tables in source and target have exactly the same data. How do we test views? Well, again, we run the views, we select from the views, we compare that they are returning exactly the same data. And now, actually, let's go to functions. How do we test functions? By the way, let me uncheck show broken reference, because I said we have to plug in our new Postgres static analysis fully. This is a fairly old version. So yeah, how do we test functions? Well, the function has a parameter here. And if we add a test, sorry, no, it doesn't. This one doesn't get a parameter. It's returning a number. So I have created a new test for the function. But if I try to click it again, it's going to fail because the test with the same data already exists. Yeah, no parameters here. But if we find a function with a parameter here, and I start and click test, how do we test functions? Well, we call them with a specific parameter. And why do we have 230 here? Why? How did this number came into existence? Well, we have SQL Tran employees table, right? So we know that P department ID is compared to SQL Tran.employees.department ID, and we have generated data. So we can actually, when you go and create a test, we'll sample the data for you. So you can specify your own value, so you can overwrite, or if I click test, well, now it's a different one, but it's the one that exists. So if I go click run test, look, it returns the exact same result in source and target. So for the parameter P department ID with a value of 170, this is returning 38, right? Okay, here is an example where Postgres is slower. All right, and now an interesting part. How do we test procedures? Well, procedures are tested by calling them. And because we have static analysis here, we know that this specific procedure is touching 2 tables. So after we run the procedure in source and in target, we're actually going to go and compare SQL Tran employees and SQL Tran job history in both source and target database, and they have to have exactly the same data. And then we're going to roll back. And if the procedure has in-out parameters, we're going to compare that as well. If they have out parameters, we're going to compare that as well. If the procedure is sprinkled with debugging selects all over the place, well, we'll compare all these data sets that are returned as well, right? So basically, procedures are tested for the side effect, which brings us back to the testing of triggers. We don't and we cannot test triggers one by one. What we can do is, and what we do is, we turn them on, we leave them as they were, and then we run all of the procedures. And it has to have, the end result has to be the same. All right, so as I said, this is all nice and well, but who would create all these tests one by one? Well, how about this? I can go to the tests here and I can say generate new tests. Well, how many tests would I want? Let's go with 5. All right, so this is automatic test generation. So we have 5 tests generated in sub-second with all the valid parameters. So if you copy your anonymized data from production database, you will recognize these parameters. And again, nobody is stopping you from creating your own, right? Now I can run tests for this. And what on earth is going on here? I think this never happened. Incredible. All right, let's go back here. Let's see what's wrong here. I'm actually going to go and test on the large scale. Generate test for all tables, 833. Generate test for all views. I have a bunch of procedures that are not tested. Generate test for all procedures. Let's go with, let's say, 3 tests per procedure. Okay, it's going to take a while because we are sampling the data from the tables. And all right, so now we have 163 tests for procedures. Let's generate tests for all functions. Let's go with 20 because why not? And we can even generate tests for the procedures and functions inside packages, right? So we have a bunch of packages here. For all package procedures, let's go with 5. And let's go for all package functions. Let's go with up to 5. And we have a ton of tests. And if I click run now, let's see how this works. All right, so first we are testing tables. We are testing tables by reading the source table, reading the target table, and comparing them that they contain exactly the same data. Because if the data is not exactly the same, well, nothing else will work. Views will return different data, procedure will have completely different side effects, and so on and so forth. Functions touching the tables will then also not work, right? But we have created 1,700 tests in just a few seconds. And I could have created up to 20 tests per object in one go. We didn't give you the opportunity to create more than that because why would you, right? When have you seen a database with when have you seen migration project which has more than 20 tests per procedure? I'm pretty sure never, right? Yeah, okay, so this one is fairly slow. But we are now running procedures. And again, depending on how many tables it's touching, we are comparing all of the affected ones. And all right, I have 5 failing tests for a procedure. And which one is that? So this one has 3 tests failing. And yeah, but this is about the timestamp. So this can actually happen. And so just for the reference, 99.9% of all of this code is behaving exactly the same in source Oracle and in target Postgres. And that's in idiomatic open source Postgres, right? All right, so now let's see what is going on here. So if I can search for the ones where things are failed, or I can basically say, give me just the ones that are failed, and only one procedure is failing. And when we look at why is it failing, let's see if we can figure something out. And you get to sometimes the timestamps are behaving just slightly differently here. And so what do we have here? This is, I think, first time I see this. Yeah, okay, so I currently have no idea what is going on here. Oh, my guess is, actually, I don't have a good guess. But still, 99.9% is the test thing, right? All right, so now what I want to show you further here is if you go to the workspace and clear filters here so I see anything, right? We have 1265 objects, but if we go to target, actually we're going to have a bit more objects. And why? Well, because we are going to unpack the packages into two specific schemas, right? So we have packages here, and the package is named, for example, array type, complex type counter, my package, and so on and so forth, right? So if I go and search for my package, you'll see that from this one, we have two types, we have one procedure, and we have 5 functions, right? And I can go there immediately. So yeah, all right, let's see what happens, for example, if I think I have an example with nested procedure. All right, so we can infinitely nest procedures. And before we used to have top level procedures, now we nest them as well, right? And you'll see that we have actually added a parameter to make this work, and you can see that the tests are passing. So this really works. And I think actually I've shown enough. So I hope you agree that this is working beautifully, right? If not, I'd like to hear why. But I'm super happy with what my team has pulled off. And now I'm gonna, for the end, I'm just gonna show you how fast the translator is, right? So if I go and search, for example, into for all here, right? And I can find all kinds of examples using for all loop. Well, first thing you can see is we are not building a loop here. We have converted this into super efficient set logic. So this is an optimized construct in Oracle. Equivalent direct translation is not optimized in Postgres. Let me go to Scratchpad. I'm going to paste this here. So again, this is just for me, very good for the demo. So I'm going to show you how the translator actually works here. So first, I can, for example, delete the exception. You immediately see it being deleted from the target. I can go ahead and start changing a bunch of things here. And it's going to be immediate. Give me a sec. So I forgot I have disabled this. Yeah. Okay. So what I want to show is the static analysis here, right? So I can rename something and break the code, and it will immediately show you that, right? Same thing here, right? So whenever something is used, you'll immediately see this breaking. And what I want to show you, again, we use the static analysis to give you the great translation. So code is not translated by, slightly modifying the source. It's translated by building a full in-memory semantic model, transforming it into equivalent to Postgres, and actually we do it trying hard to optimize it from the get-go. So for example, if I now go and say save, by the way, if I make a syntax error, you'll immediately see this, right? However, take a look at this. I have added save exceptions clause to this for all. I'm going to comment it out. Please compare the target, and you see how quickly we can do that. So yeah, going from source, we built a completely different thing. But what's important is we build what you would have highly skilled developers write by hand. We do this in sub-seconds. So if you want to translate, migrate complex Oracle database to Postgres in-house, you can do so now. It's much, much easier, right? If you have outside consultants whom you want to do this, well, now you have freed up most of their time to provide value, to look critical into the code. They have performance testing, right? We have reports on performance, we have reports on correctness, and well, they can go ahead and rewrite the logic by hand to get this the Postgres performance to be always in, always in all the instances where it matters to you. They can rewrite it completely, right, and optimize it for you. So we have unlocked translation migration of the very, very high risk and very typically very expensive and very long projects. Well, we have de-risked it and we have made it much, much simpler now. All right, so that's basically all I wanted to show you. I hope you find this truly revolutionary like I do. Yeah, now, how would you actually get this thing? Well, and you ask, we have launched it. So if you go to SQL Tran, actually, let me go to our website. I'm gonna show you our website here. So cool. So this is our website. In our website, we show our migration suite, individual projects, right? And if you go to SQL Tran, you can go to the app right now. By the way, maybe best to talk about the pricing now. So we are pricing per nodes, and the nodes, actually, let's go here. The nodes are this thing here, right? So this database is using 55,000 nodes. How many you will use? Well, it depends on your specific database, right? But yeah, you can go from 4K a month all the way to unknown amount of money, because we can also provide this for the enormously complex projects. We can even provide our own, our consulting arm can do everything for you. If you're in Australia, we have a partner in Australia who will take care of you. If you're a consulting agency anywhere else in the world, please reach out. Yeah, please go ahead and look at our pricing page. And if you want to get started right now, well, you can do so for free. If you go to the app and you don't have an account and you register, you'll be able to get instant assessment, right? You can click here and get the assessment report immediately. You will see translation of just, I think, 3 objects per type in your database, and for the rest, you will not see the translation. But the full assessment report plus this sample of the translation and what you have seen now from me should really make you comfortable in working with us. So yeah, you can get instant assessment if you're, and you get, by the way, the way we do assessment is we do this full translation. We just hide the result from you, so you cannot just get everything for free. But the assessment report is telling you not what it thinks is going to happen during the translation. The assessment report is just surfacing findings during the real translation, right? So if you go to the our website and go to the application, upload your Oracle script. Don't worry, we won't look at it. You can get instant list of all potential issues, how much are you able to translate right away, and you can download this assessment report and take it to the whoever is in charge. Once you get the approval, you can click unlock the project and or request a quote. We'll send you a quote, and you'll be able to unlock the project and instantly achieve what I have done here for you. Okay, I hope you're satisfied with what you're seeing. Please reach out either to me directly on LinkedIn, perhaps. Reach out to us. There's multiple ways to contact us on our website. And I hope if you are struggling with Oracle to Postgres migrations, or if you just have many projects and would like to have more projects at scale, well, you can do so easily. Okay, so Steven's question is, how do we create the Oracle file to upload the SQL Tran? I actually spoke about this in the beginning. So let's do this again. Home, new project, Oracle. Now, if you have already made schema dump, you just click here or drag and drop and we'll do everything. If you don't have it, well, there are several possible ways. One, you can connect directly to your source database, maybe a replica of the production, or if it's sensitive, some kind of anonymized or whatever your source is. By the way, we don't use data, we just read the schema, but still. Then if you want to build this from the command line, we provide free of charge scripter tool, which has the documentation. And the documentation is basically, it's here. And if we go to, let me find it, where is my Oracle here? Why cannot I find it? Here, right? So this is documentation for scripter, but then again, manual extraction, we provide ready to use function. So just run it and yeah. So it's a schema dump out of Oracle. We don't even need the data. If you want, use this use SQL Tran in combo with OmniLoader, and you have everything. You have the ability to translate code, create target schema, load all of the data. Even if you're talking about 100 plus terabytes, OmniLoader will just do this out of the box. If you need CDC, you can just have the Oracle transactions being streamed to the Postgres target in real time. OmniLoader is used for that. And once you are happy with this, you're ready to make zero or close to zero downtime migration to Postgres. Yeah, are there any further questions? By the way, we have plenty of new announcements to make. So just in June, we're going to make 2 new announcements. The software is, as it is now, we still have some work to do. But yeah, at one point, you need to release. And when I say we have some work to do, well, we've done so much more, I think, than anyone else on the market already. And we just have so many great ideas still to come. Okay, let's see if there are any further questions. Well, no. All right. I'm available on LinkedIn. If this looks interesting to you, please reach out. I'll be happy to talk to each and every one of you. Discuss your projects or challenges, right? We have a team ready to help you. We have a team of experts. And yeah, maybe it's best if I give you my LinkedIn page so you know where to reach out. So with a little bit of luck, I'm actually going to figure out where to paste this into the chat. And now I can see your messages. I cannot figure out where to paste. Anyway, please find me on LinkedIn. It's linkedin.com/ let me see, /what? DBULIC. So DBULIC. A little bit of luck, you'll find me. I'm very curious at what you think, what you feel, what you still perceive as challenges. Yeah, so thank you, Nemanja, for pasting that link. Cool. So I'm super happy that we have finally released it. We planned to release this last year, but then we had integration with Microsoft Fabric, which took at least 3 months, and then there's just last 10%, which takes enormous amount of time because you get to the edge cases and edge cases. But now I'm super happy with where we are. I believe this is revolutionary. I believe this is completely going to change the market. But yeah, please reach out to me on LinkedIn and tell me how you feel, and happy to talk. So regarding the sysref cursor, let's see. Yeah. So Raja, we are covering sysref cursor translation. How do I know? I just searched for it. We're covering all of these edge cases. There's still quite a few to come. But yeah, we have the tendency to do the hard things first. And now comes all the tweaking of the user interface, making things even easier, and more integration with OmniLoader. So this should be, hopefully this is going to be very popular. We worked very hard for this. Okay, that's all, folks. Please, again, reach out to me on LinkedIn. I'm super curious to hear what you think about this. If you feel this is great, talk about us everywhere.